Okay, so I'm going to try to walk you through the use of Excel and how you should be doing your data analysis. And I'm going to do a quick run through on how to do an ANOVA test and how to graph your data. And so I want you to use the sample data set that's posted online in Google Classroom to model this data or data analysis so that when you do your own data analysis, you can follow the same steps and the same reasoning. And we'll talk through a little bit of this in class if you still have questions, but you can follow along. I will also post my data set here. So if you are unsure of your steps, you could run through my own data and see if you get the same values. And if you do, then you're doing the right thing. But I'm not going to grade my set. You can use it for practice. I'm giving you the other random data set that I want you to analyze and then submit. So let's go ahead and get started. Here is my research question. I'm just giving you a little bit of background on what I'm doing and what I'm trying to evaluate. My research question is, how does the amount of light exposure affect the height of, I should say fescue, not fescue, let me correct that now, fescue grass seeds. And doing some of the background research, I'm not citing anything, but I'm modeling how background research is going to inform my question. So I know that fescue seeds are used for partially sunny and partially shady areas. So these are parts of lawns that don't get full amounts of sun. So knowing that, it's going to affect the levels of my independent variable that I will select. So here, what I'm showing is, therefore, the levels of my independent variable, or the amount of light exposure, should be narrowed to the mid-range. Instead of testing ranges between 0 and 100%, I'm going to test right around 50%. That's partially sunny, partially shady. So you don't need a page like this, but this is just to give you some framework of what I'm doing. And this is my data. So what I've done is written in this first cell my 5 different levels, 40%, 45, 50, 60, and 65%. But I realize, yeah, so these are not evenly spaced, 50 and 60, 65, and that's okay. It doesn't have to be. It probably would be a better experiment, maybe, if they were closer in range, but it doesn't have to be, and we'll talk about that in the data analysis. Notice, though, that my ranges are continuous, because I could have tested 40%, 41, 42, 43, 45, 44, 45, if I really wanted to, or I could do between those. I could do 40.5%, 41, 41.5. And so all the data continues. They're not discrete or separate pieces of information. I'm not testing the amount of sugar in different candy bars, right? A Mars candy bar does not transform into a Baby Ruth candy bar. They're separate things. So this is continuous data here, and underneath are my data points. And so if we go back to the research question, what I'm measuring is the height that the grass seeds grow. So these numbers represent height. I do not have units here, although I know I should have the units, and I know those units, but they're not here. And when it comes to uncertainty, which I want you to ask me about in class, I'm not going to spend time on that now. I know based on the uncertainty of my measurement that I'm rounding any measurement to the closest 10th place of a centimeter. And so I'm rounding. And so to account for that uncertainty, I need to go one more decimal place to designate that. And I've got different amounts of decimal places. This cell, 3.4, has 1 decimal place. This one has no decimal places, but I really need 2 decimal places. So I'm going to select these cells, right-click, and go to Format Cells. And I'm going to click on Number, tell it I want 2 decimal places for all of those cells, hit OK, and it added them in. And so now I don't have a formatting issue. But I need to do some statistics to this. I could kind of eyeball this and say, well, I think that the 60% range is the best group, but I can't really do that systematically. And I've got 5 points of data underneath. I could find averages, and we know the problem with just finding averages is that an outlier could throw off my data. This 0 is going to throw off this group. And the real solution to that is to have lots and lots of data not to throw this data point out necessarily, unless I know something happened with that trial. But if I had more data points, let's say I had data all the way down to 17, this row 17, or hundreds of data points, then this 0 would be averaged out. But I only have 5 data points, which is sufficient for you for each level. And we'll just account for that. We need to make sure we talk about that in our conclusions and evaluations. So what I'm going to do is transfer my levels over to this side, but I don't want to leave it in percentages because I'm going to use this to make my graph. So I'm going to go back to Format Cells. Oh, I copied it by highlighting, hitting Control and C, and then Control and V to paste it. I'm going to go back to this. I don't want it in decimals. I want it, let's see if I can, I think I'm just going to go to General and hit OK. And what I might have to do, just for ease of time right now, I'm just going to write 40, rewrite it as 40, 45, oops. Hit Tab to go over to the next cell, 45, 50, 60, and 65. You could have left it in those proportions if you wanted to, and that's fine. What I'm going to write in this cell is not, so I'm going to want to write average, or better yet, mean. I'm going to write standard deviation. Double click on this to make that longer. And I'm going to calculate these values. So you could calculate these values by hand. Excel will do it for you nicely, so I'm going to show you how to do that. I want to select the cell that I wanted to calculate the average into, and then I'm going to hit FX for the function key, double click average, and then in this first row it's going to ask me to select which cells to pick. So I could click on this blue button and then select these cells, or what I'm just going to do is go ahead and select those, hit OK, and it puts my average of 4.18 into that cell. Now, because this is processed data, I need to go actually one more decimal place. I'm going to select all the cells I'm going to put that data into, right click, click on Format, go back to Number, put 3 decimal places, and there's my value. Now, I could redo that whole process for this cell and pick the next column of data, or use Excel for how smart it actually is as software, and hover over the little green box in the corner here. My mouse turns into these crosshairs. I'm going to click, keep the mouse button down, and scroll to the right. And it applies the formula all the way across. So now I've got my averages for each group. I'm going to do the same thing, a similar thing with standard deviation. I'm going to go to Function, click in STDEV, and I'm going to pick the same data points. I don't want to pick the average, I'm going to pick the raw data because it's telling me how far each data point is from the average, or the average distance for each data point. This helps me account for outliers within the group, and there we go. Now I've got my data there, but I still don't know. This is all descriptive statistics. I don't have any hypothesis testing. I'm not testing my hypothesis that one of these 4 levels is better or allows the fescue grass seeds to grow better than the others. So I want to test that. But let me just make one thing. You don't have to write this on yours, but let me just add a note here that you should be aware of. So there are 2 types of hypotheses. You've been trained really well to write the first type, which is called an alternate hypothesis, which is really saying in some way you could write your if-then sentence or just your prediction, but what it's really saying is that one or more groups are better than other groups, or another group, right? So you're just saying that there's a difference. The other kind of hypothesis is called a null hypothesis. And keeping in mind that we never use the word prove in science because we could always learn something to disprove the idea that we had. We're not trying to prove things. In fact, we try to disprove simple ideas. And so the null hypothesis is the idea that there is no difference between my levels. So in this case, my null hypothesis would be that the fescue grass seeds don't grow at any different height, when exposed to 40, 45, 50, 60, and 65% of their normal light exposure. And so my goal is to actually disprove that null hypothesis, which would then support an alternate hypothesis. It may not be the exact alternate hypothesis that I think. So I might think that as the amount of light exposure increases, the plants will grow taller. And I think that because I know that plants need light for photosynthesis. But that may not be the whole story, and that's what we're trying to figure out. So in order to compare these different groups, because I have 5 levels, because it's more than 2 groups, I have to use something called, I'm going to put it right down here, an ANOVA test. So that stands for analysis of variance, and it's showing me how each group is different from each other. So I'm actually going to click on a cell down here, leave a little bit of space, and I'm going to go click on data. And you'll see a bunch of stuff up here, and you may or may not see this button over here under analysis called data analysis. If you do not see that, you need to try to add it to your Excel account. If you cannot add it, then you're going to need to jump over to another video that I'm going to make that's about alternate ways to run your ANOVA data. But if you don't see it, try adding it by clicking on File and Options, and then Add-ins. If you click on add-ins, you will see 2 things that you could add. I've already added mine, so I can't add it again, but I'm going to add my analysis pack, tool pack VBA, and instead of hitting OK, it won't do anything if you click that. Click on Go. And if you click on Go, this data analysis button in the background over here will pop up. So I'm going to cancel because I've already done that. And then I'm going to click on data analysis. And I'm going to run an ANOVA test. It's a single factor test, which means I have one independent variable that I'm changing. And I'm going to click OK. And it's asked me for the input range. I'm picking all of my data plus the row that has my titles for my levels. And I'm going to make sure this box is clicked labels in the first row so it can organize that data. I want to make sure my alpha is at a 0.05 level, which really means a 95% confidence level. And it asked me about that as well in class. And then and they're grouped by columns because my data is going down, but you can organize it another way if you like. And then I don't want it to go to a new workbook or a new page. I want it to be on this page. So the output range is 1.6 or I6. Well, I want it in this cell, so I'm going to click on this blue button, click it on that. So it's G19, column G, row 19, and then hit this gray button and hit OK, and a bunch of data pops out. This is a lot of information, and by no means do I want to see this in any kind of report or presentation. There are 3 values that are really, really important, and it's these 3 right here. So what I'm going to do is hit Control-C after highlighting that and throw that up here underneath the title I had written for ANOVA. I need to reformat those numbers. This is a crazy amount of digits. So for consistency's sake, because my raw data had 2 decimal places, my processed data over here needs 1 more, this is still processed data. So I'm going to pick these cells, right-click, click on Format Cells, and make this 2 decimal places again. Sorry, 3 decimal places. And this is how it gets reformatted. Now, one thing I don't like that happened is my p-values got rounded down to 0. So if I click on undo, what I may want to do is pick this cell and then this cell and do that so I can leave my p-values just as it is, because I don't want to reformat it to something crazy like that. So I'm going to do that real quick. I want to tell you to do it and then not do it myself. Okay. Okay, so what this really tells me, this tells me a lot of information, even though it's just 3 digits. And so I'm going to write it out here on the, I'm going to actually write it over here on the left, how to interpret an ANOVA test. So, so there are 2 things you need to know, is that if the F value, which actually I'm going to retitle as my F calculated value, if the F calculated, the F calculated value is greater than the F critical value, there is a significant difference. And significant difference is a very, very important term. That means that it is significant beyond some measure, some criteria. And here we're talking about a significance value of 0.05. So I'm going to say with a 95% confidence value. Okay. So let's see if we can. Sorry, I just reformatted a couple of things so you can see all the text. The other way to read this is the exact opposite, right? So for the other cases, if the F calculated value is less than the F critical value, there is not a significant difference. And that's not the same as saying insignificant difference with a 95% confidence level. Okay? So this is very important language to be able to use. And when I say if the F calculated value, I actually want you to tell me what that F calculated value is. So with an F calculated value of 16.092 and an F critical value of 2.866, there is a significant difference between the groups with a 95% confidence level or value. Alternatively, you can also see that the p-value is less than 0.05. 4.84 times 10 to the negative 6 is less than 0.05. And that also supports the idea of there being a significant difference, which refutes the null hypothesis that there is no difference. So there is some difference. Now, we still don't know everything. We don't know which level shows the most difference, or the most growth. So we need to further answer this question. If we found that our F calculated value was less than the F critical, then we could be done and say that there's no difference between any of the groups. But we know there's a difference. We just don't know where the difference is between these 5 different levels. So we need to graph it and then do another series of analysis. So what I'm going to do is graph this data, not the raw data. I don't want to see a graph of your raw data. I want to see the graph of the process data. So what I'm going to do is select these top 2 rows, which has my levels, the label of my levels, and my mean values. And this is really important step to follow. Students mess this up because they're not paying enough attention to the detail of what I'm doing. So we've got this value, this system here. And what I'm going to do is click on Insert, and I want to click on this chart that's got a scatter graph because my data is continuous. If you were testing different groups of things, which you probably shouldn't be, but if you happen to be, you would use a bar chart. You would use a bar chart like this, probably this one right here. But for this case, we are going to use this diagram right here. And so once I hit scatter, my data comes in. I'm going to scoot this over to the right just a little bit. And I've got my mean values plotted. But if you were to turn this in, this means nothing. I don't know what this means. So I have a new version of Excel. You might need to right click and format some things, but I'm going to hit plus. I want axes titles. I'm going to add those, and I don't need data labels. I don't need that because that's just a little too cluttered. I do want error bars, but we're going to clean that up, so I'm going to leave that right now. I don't need a legend because I only have one series of data. And I don't need a trend line per se, not for this graph. But looking at this data, I can see, just as this case shows, that maybe the 50% has the highest rate. But I have not accounted for outliers, and I want to see how far spread out the data is and see which groups are better than which. 40% looks, the 40% value looks higher than the 45%. But there may not actually be a statistically significant difference between these two groups. So let me go and add my titles so you can see exactly what I'm doing. So I know that my x-axis is the percentage of light exposure. And I already told you the unit by saying percentage. And for my axis label, I'm looking at the height of fescue seed growth in centimeters. And we've got some funny formatting to deal with because we could change some values in our percentage here, which, you know, I should have done before, so I'm going to go back and do that, and it should update it. I want to right click and go to format cells, and I want to add 1 decimal place. And that changed it on my graph, and that's exactly what I want it to be because of the uncertainty of my measurements. And over here, I've got other issues of what that value of height is, which I can fix as well. But I'm not going to focus on that right now. Or perhaps I should. But we can talk. That's pretty quick to figure out. So what I'm going to do is change a little bit of my axes range. I've got all this blank space over here that I don't need. And despite what you might have been told in math class, I don't always have to start at the origin of my graphs. So I'm going to actually close this down a little bit. So I'm going to click on this axis, double click on it, and move over to my options here. And bear with me, this is new. This is a new way to do this for me. So I'm trying to figure out. Here we go. Under axes options, I don't want to go from 0 to 70%. Really, I want to probably focus on my lowest value is 40. Maybe I'll go to 35% as my lowest, and the max can still remain at 70. And I'm going to click out of that, and it reformats my graph, so it's a little bit more spaced out. I can maximize what is visible here. I didn't put the chart title. So this is the effect of the percentage of light exposure on the height of fescue seeds measured in centimeters. And in fact, I would put something in here. I'm not going to, and it's going to be a value that is plus or minus my uncertainty. So, and that should be labeled here on the axis as well. But we'll talk about that in class. So, not done. This still doesn't tell me which groups are different, so I need to add my standard deviation error bars. So I'm going to click again on plus, or you'll add right click or add error bars. And I'm going to click on error bars. And I've got 2 sets of error bars, vertical and horizontal ones. And I don't care about the horizontal ones, because that's not showing me variation in my data. Excel just thinks that's what I want. And so if I go back to error bars and click on the right arrow, I want to click on more options. Even though it says standard deviation here, it really doesn't help me in what I want to do. It's picking one standard deviation value and applies it to all data points. But we know from our data analysis that not each level has the same standard deviation value. So I click on more options, and if I click on this over on the chart diagram over here, it's set for standard error, but I don't want it to be set to standard error, and I need to see what, I'm looking at the horizontal error bars right now. I don't care about horizontal error bars, I want them to be 0. So if I click on fixed value and then put in 0, they will go away. And then if I click on, I forget. Oh, if I click on error bar options and this arrow, I want to go to series 1 error bars, and this is the vertical error bars. So I'm going to go to custom, and I want to specify the values that I want. So it's going to ask me how high do I want, how much above the data point I want the error bar to go, and how much below it. And I want it to go above 1 standard deviation and below 1 standard deviation. So all I'm going to do is select these cells for the positive and the same cells for negative, and hit OK. And now my standard deviation error bars are in place. So what I can see visually from this diagram is that despite the fact that the 40 and 45% values of mean are different, the standard deviation error bars overlap. So there's not likely a significant difference between these two groups. But these two groups do not overlap with the 50% light exposure, and therefore there's likely a significant difference between these than the 40 between this group of two values and the 50%. There's also not likely a difference between 65 and 45, but all of these look different than the 50, and the 60 seems to not overlap with the 65. So there seems to be a kind of set of differences here. So let me just model one set scenario that you could do for further analysis, and that would actually be a t-test. So a t-test is an analysis between two levels. So it looks like there's a difference between 45 and 50, so I'm going to analyze that. And so what I'm going to do is this spreadsheet gets a little more complicated. And what I'm going to show you is that t-test. So I'm going to go back to my data analysis. Oops, it's telling me something's wrong. Okay, so I want to go down to t-test, and I'm going to assume unequal variances. So two sample assuming unequal variances. And click OK, and it's asked me for the variable 1 range. So I'm picking my 45 degree values. Oh, and I actually want labels. So I want to pick that top row, and I want my other group. I'm going to click labels, my alpha, and then I've got my output range that I want down here. I'm going to click OK. Oh, you know what the problem is? It's in this row, so I'm going to actually want to put it over there. So let me run through that row one more time. So I want the t-test, assuming unequal variances. I still have the same data that's already in there. I want my output range to be over here. Hit OK. And down here, I've got the same similar kinds of data over here as the ANOVA. And what's really important here is, let's see, what I want is my t-stat, and my P two-tail and T critical two-tail values. So these are the values that are really important to me. And even though this is a negative value, we should think of it as an absolute value. So it's 5.4. And because it's the same analysis as the ANOVA test, this right over here, it's the same kind of thing. Instead of F values, you put in T values. And because 5.4 is greater than 2.36, there is a significant difference between these two groups. The other piece of information that helps is that my p-value is less than 0.05. And so I can tell that there is a significant difference between 45% and 50% light exposure. Okay, so that's the idea that I want you to be able to do. And if you can run through that, great. I'm going to make another video that shows you how to report this data into appropriate data tables. And that should be really a much quicker video.